Okay, here is our next proof. So we're given two pairs of parallel sides again. Okay, so in this picture, it looks like we're given that segments BC and AD are parallel, and segments AB and CD are parallel. Notice how they're marked, right? Parallel, 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 parallel. And we want to prove that angle BCD. So BCD, this big corner angle, is congruent to angle BAD, this big corner angle. Well, notice that those two corner angles are made up of two angles each, right? So somehow I think we have to speak about those individual angles. And again, eventually we're going to add them together to get the corner angles. Well, let's take a look at one pair of parallel lines at a time. Okay. So let's take a look at BC. So I'm going to trace them. Watch what I do. BC and then AD. And then this line AC is my transversal. Watch, I'm going to trace that. And do you see the letter that I've made? Do you see the Z? The Z creates two alternate interior angles, because if this is the transversal, I have one angle here, BCA, and I have one angle here, DAC. They are going to be congruent because they're alternate interior angles. Now, just to think ahead, so I don't have to do so much like drawing, what about sides AB and sides CD? What if I draw this transversal again? Now I have an upside down N or a sideways Z. But again, this angle BAC and this angle DCA are going to be congruent. And now look, aren't the two big corner angles at A and C made up of congruent angles together? So they should be congruent as well. And that's the proof. That's the chess match. That's the roadmap set out directions. Let's just write them down and follow them. Okay. All right. So again, let's use BC. So that means that angle BCA. And let's use side AD. And that means angle DAC. So these two alternate interior angles are going to be congruent because if your lines are parallel, you have congruent alternate interior angles. Okay, and they're marked, right? Look. Okay, let's do the same thing with the other pair of angles based off the other parallel lines. So let's do AB, so let's do BAC. And then we have CD, so let's do DCA. They're again congruent because of the same reason. We have parallel lines cut by transversal, alternate interior angles are congruent. Boom. And they're highlighted. And now, if we add the two angles at A together and we add the two angles at C together, those big angles will be congruent as well. I think we're done. I think that we can say that angle BCD is congruent to angle BAD. What I want to prove. And this is like an angle addition reason, but you're not going to see that in this list. So let's look. It says if two angles are complements, no. If two, no. Congruent angles added to congruent angles form congruent angles. Added. That's the key. So kind of look through the list. Again, I think that's angle addition in their minds. And boom, green check mark, and I am done. Awesome. Okay. And again, you can always take a look at their steps too to see what they did, but it should be the same thing that we did. Okay. All right. Second problem coming on this video. Okay. So in this problem, we're given that angles BEA and FDG are congruent. So that's this angle here and this angle here. Again, we can hover over to highlight them. We want to prove that angle C and angle CBE are supplementary. So let's take a look at where these two angles are. These two. So where's angle C? Angle C is right here. If they only name it with one letter, that's the vertex. So this is angle C, obtuse. Where's angle CBD? I'm sorry, CBE. Right here, acute. Now look at that, right? What if I highlighted that side? Don't these two lines look parallel? Couldn't this be the transversal? What type of angle pair would they be? They're on the right side of the transversal. In the interior, aren't those same side interior angles? And aren't same side interior angles supplementary if the lines are parallel. So there's our goal. Can we prove that these two lines are parallel? Right? Well, we have this angle here and this angle here to work with. Let me do that in red. Well, they're not a special angle pair. But if you remember, didn't I talk about we can use other angle pair relationships to then create these favorable relationships? Isn't there a vertical angle to this angle right here? Look, and vertical angles are congruent. And now look, I have this angle and this angle congruent. This angle is in the same position as this angle amongst these lines and this transversal. So these two angles are going to be corresponding angles. And because of the vertical angles, now these two angles are congruent. And if corresponding angles are congruent, then these lines are parallel. And if those lines are parallel, then the two angles we want to prove supplementary are same side interior angles, and they are going to be supplementary. And that's the proof. Vertical angles, corresponding angles show parallel lines, and then parallel lines create supplementary same side interior angles. Okay, so that's the proof. That's the chess math. Let's walk through it. So first thing I'll do is I'll mention the vertical angles. So we're going to say another pair of congruent angles. We're going to use FDG again. But we want to use this angle. I'll call it CDE. That's because vertical angles are congruent. And now you notice, look, they mark those congruent. And now I have a pair of corresponding angles. Now I have to say that they're congruent in the proof. So this is BEA, that's this angle. This is CDE, that's this angle. So I need to prove that they're congruent. Angle BEA is congruent to CDE. And again, if you remember from our I think it was the 2.5 video again about these proofs, that this is the transitive property. If A is congruent to B, and B is congruent to C, then A is congruent to C. Again, this idea that we take out the middleman, right? So this guy is common to both. So we take him out and we connect the two outside angles with congruence. And again, that's the transitive property. And now we have a pair of corresponding angles congruent. We have parallel sides. Let's call it CD, the top one, and let's call it BE, this middle side. And this is going to be because you have congruent corresponding angles. If two lines cut by transversal form congruent corresponding angles, then the lines are parallel. And if those two lines are parallel, then the two angles we want to prove supplementary are same side interior angles. They will be supplementary. We're at our prove statement. We want to prove that angle C and angle CBE are supplementary. And since we have parallel lines, we're looking for those reasons. Parallel lines cut by a transversal form same side interior angles. Check mark. Done. Cool. All right, so there's your fourth proof. All right. Next video, 2 more proofs coming.